Uh, t- Today I am discussing with you a problem from Irodov. I am daily uploading problems on Irodov, but this is for the first time that I come live on the class. And this is a problem, advanced level problem for in rotational dynamics. And on in Irodov it is 1.281, chapter 1 and problem number 281. Yesterday I uploaded problem 280. Every day I am uploading the problems on rotational dynamics. So this is a problem. A horizontally oriented uniform rod AB of mass m is equal to 1 kg and length वहाँ mass 1.4 kg है, मतलब I will derive the formula for you, and length L is equal to 100 centimeters, rotates freely about a stationary vertical axis OO prime, passing through its end one of point A. It is not end A, point A. The point A is located at the middle of the axis OO prime, whose length is equal to L is equal to 55 centimeters. At what angular velocity of the rod the horizontal component of the force acting on the lower end of the axis OO prime is equal to 0? This is the question. You can read the question again for yourselves. A horizontally oriented uniform rod AB of mass 1 kg, but there in the Irodov I think it was 1.4 kg, and length L is equal to 100 centimeters, rotates freely about a stationary vertical axis O prime, passing through its end A. The point A is located at the middle of the axis O prime, whose length is equal to L is equal to 55 centimeters. At what angular velocity of the rod the horizontal component of the force acting on the lower end of the axis O prime is equal to 0? This is the question. So let me start doing this question. The question is like this. It is the axis. It is axis also, and it is also you can say it is itself a rod of length L, and at the middle of this rod is a huge rod like this whose mass is m, and it can rotate because it has a rotational freedom here at this point A. It can rotate in a circle around this A, around this rod A. This rod is itself an axis O prime O, and here it is fixed. Here the rod is fixed, and this rod rotates around this rod about this point A, and also you see these 2 points of this rod are fixed. The question is, when it rotates, this rod rotates, the force at this point, horizontal force at this point must be 0. It must be 0. Here F should be 0, F prime should be 0, and here F should be something to balance this force. This rod rotates. So if the rod rotates, please tell me at what frequency it should rotate around this point A, at what frequency it should rotate about the point A, so that force here should be 0 and all the force is balanced by this end. Suppose this creates a force at this point, force is F here, so that while this rod is rotating and there is a centrifugal force needed to keep the point A fixed or to keep the rod A fixed, there must be a reverse force F to balance that force. Basically this force rotates because this centrifugal force also rotates, क्योंकि इस वक्त ये सर्कल में घूमता है और ये फोर्स जो है F centrifugal is equal to mr omega square, and the length of this rod is L0. तो ये centrifugal force है about this A, yeah, with respect to this rod there is a centrifugal force. When this rod rotates, this force must be balanced by this force and also here this force. But we have to see what should be this frequency of rotation around this of this rod, so that force here is 0 and all the force is, this force is balanced by only this force. That is the question. The rod rotates, there is a centrifugal force, and this centrifugal force is being balanced by the force at the upper end, not at the lower end, because lower end should create a force 0. There should be no pressure on this lower end. How to do this problem? First of all, okay, there's mg also downwards. First of all, I will write an equation that is, this force is balanced only. I will assume this force F prime is 0. Let me assume. अगर मैं assume करता हूँ, then it will lead to other things, F and omega. Let me assume this force is 0. When I assume this force is 0, it will lead me to other things. It will lead me to other things which I have to find. So first of all, ये जो F है, this I will write as m or omega square. This one. This force, if it is not fixed and it starts rotating, it will fly away. It cannot rotate unless this force is balanced by some other force. So it is the force that balances this, because this I have assumed as 0. He says, अगर ये 0 यहाँ force है, तो omega क्या होना चाहिए? What should be the rotational frequency of this rod around this axis, so that the force here at this end is 0 and it is being balanced only by a force at the upper end. तो वो ये force भी निकालना है. तो पहला इक्वेशन मैं ये लिखूंगा. दूसरा इक्वेशन जो मैं लिखूंगा, the torque must be balanced about this O, because this point is fixed. So the torque about this point must be 0. So what is the torque produced by this mg about this A? That is mg L0 by 2. This torque should be balanced by this torque due to this force. What is torque due to this force? अगर ये पूरा L लेंथ है, तो ये तो आधा लेंथ L by 2 है. तो ये torque is in this direction and it creates torque in this direction. This is anti-clockwise torque. This is clockwise torque and this is anti-clockwise torque. These two torques should balance out. Because there should be no torque about this point A. So I will balance the two torques, mg L0 by 2, and this torque is balanced by this force torque, that is FL by 2. ऐसे. अब मैं इन दो इक्वेशंस को यूज करके ये ओमेगा निकालूंगा. लेकिन यहाँ और एक चीज है, it is m, this r is m r omega square is the centrifugal force. This r is equal to L0 by 2. L0 by 2 omega 0 square. तो इन दो इक्वेशन को यूज करके मैं इस क्वेश्चन को सॉल्व करूंगा. दो ही इक्वेशंस हैं. We have only two equations. One is the centrifugal force should be balanced by this force, because this I assumed 0, and torque by mg should be balanced by the torque by this force, so that net torque about A is 0. Because this point is about this point it is balanced. The system is balanced. So चलो इस f को सबस्टिट्यूट करो पहले. mg L0 by 2 is equal to, what is this L by 2 पहले लिखिए आप. What is f? F is m L0 by 2 omega square. ठीक, मैंने इस f को सबस्टिट्यूट किया, तो ये खत्म हुआ, L0 खत्म हुआ. ठीक, सो एक L0 तो खत्म होगा. तो अब it is omega square is equal to 2mg. यहाँ m भी खत्म हो गया. चलिए ठीक है, ओके. यहाँ m भी खत्म हो गया. It is 2g by this L is equal to omega square. 2g by this L omega square. Omega is equal to root of 2g by L. Answer. अब ये L दिया हुआ है इसमें क्वेश्चन में. G आपको पता है 10, so you can find G value of omega. So omega angular frequency of this rod should be this, so that the force here should be 0, because we have balanced this force only by this force. अगर ये 0 नहीं होता, कुछ और होता, तो this force would have been balanced by these two forces, right? So now I want to find this force created at the upper end of this axis. यहाँ पर जो ये रॉड फिक्स है, इस पॉइंट पर कितना फोर्स क्रिएट हुआ, तो ये मुझे फाइंड करना है. तो F इज इक्वल टू m. तो यहाँ ओमेगा का वैल्यू दीजिए आप. substitute the value of omega. Substitute the value of omega. इस omega का value यहाँ substitute कीजिए. So let me substitute the value here. F is equal to m L0 by 2 omega square. That is F equal to m L0 by 2 omega square is 2g by L. Right? So because omega is root of 2g by L, 2 cancels. So F is equal to mg L0 by L. Answer. तो क्वेश्चन ये था, मैं आपको समझाऊंगा और एक बार. क्वेश्चन ये था, एक रॉड है, वर्टिकल रॉड है, फिक्स्ड एट टू एंड्स, एंड एट दिस देयर इज ए हिंज अराउंड विच दिस रॉड रोटेट्स. हमें देखना है कि ये रॉड जो है इसका रोटेशनल फ्रीक्वेंसी क्या होगा अराउंड दिस ए, सो दैट फोर्स एट दिस पॉइंट इज 0 एंड फोर्स इज ओनली सस्टेन्ड बाय दिस. सिर्फ ये एंड फोर्स बर्दाश्त करता है फॉर दिस सेंट्रीफ्यूगल फोर्स. m L0 by 2 यहाँ तक, ये पूरा L0 है. सो m L0 by 2 ओमेगा स्क्वायर. सो सेंट्रीफ्यूगल फोर्स should be balanced by this force so that this rod remains fixed. Otherwise अगर ये फोर्स ज़्यादा है तो it will take this bigger axis along. तो अगर ये एक्सिस फिक्स करना है तो हमें ये फोर्स को F के बराबर लिखना है. that is m L0 by 2 ओमेगा स्क्वायर is equal to F. ठीक? Right? And also there should be no torque about this point. So torque produced by mg about this point should be torque produced by F about this A. So it is L by 2 यहाँ तक distance, और यहाँ से यहाँ तक है L0 by 2. So what is torque due to mg? That is mg L0 by 2 should be equal to torque due to this. That is F into L by 2. L by 2 into F. तो इन दो इक्वेशन से मैंने आंसर निकाला. कहो तो फिर से हम कर सकते हैं. It is mg L0 is equal to LF. L, what is F from here? That is m L0 by 2 omega square. Omega square. तो m खत्म हो गया, L0 खत्म हो गया, तो what is omega square? That is 2g by this L. So what is omega? Root of this. फिर से दिखाया, easy. तो अब जो ये ओमेगा है इसको यहाँ डालने का है ऐसे, और F निकालने का है. Easy. That was a question. So force here is 0, force here is sustains this force, and torque about this point should be 0. So every day I will be coming live to solve Irodov with you, and also within when I solve a single question, related concepts I will discuss, and I will make out of that heavy question 10 objectives, and every day I will discuss 10 objectives with those students who want to go ahead with advanced level IIT. So Irodov question, sometimes questions from what you call as Pathfinder, and with those questions I will also discuss 10 objective questions of IIT level every day with the students live. Thank you.